This is section 11.4 on sampling when you're looking for populations and so on. There's a lot of definitions in this particular section. You'll need your book. We're going to look at 2 examples from your book, and you'll need your graphing calculator. All right, some terms that we need to know. These need to be written into your notebook. First of all, we need the word population. Population is the group of people that you want information about. A sample is a subset of that population. Let me give you a couple examples. Minnesota would be considered the population, all the people in Minnesota. Rochester would be a sample because it's a subset of the entire state. So Rochester, the people in Rochester would be a subset of the entire people in the state. Minnesota could be a sample if the United States is the entire population. You could look at John Marshall students as a whole could be the population, but a sample could be the students just in my class out of the entire population of JM. So there's different examples of population and a sample or a subset of that population. How can you collect information about your people? 4 different ways we're going to talk about in order to collect your sample. First up would be self-select. Self-select is easy. Raise your hand. Pick me, I want to volunteer. Another way is called systematic sampling. Systematic means you have to follow a pattern or a rule. So for instance, every second person to walk in the door, every other person, I could give them a survey. It could be every 5th person in line is going to be pulled out of the line at the airport for further screening. So it has to be some kind of a rule. Every other person, every 5th person, something like that. The third sampling is called convenience. If it's a convenient sampling, that means it's easy for the person giving the sample. I'm going to give out a survey to my students in class, and I choose to give them only to the people in the front row because I can reach them easier. I'm not going to sample the people in the back. So as long as it's easy for the person giving it, it's called a convenient sample. And then random. Random means that everybody has an equally likely chance of being chosen. Put everybody's name in a hat and you're just going to reach in and draw one name. Everybody has an equally likely chance. If anybody was in the basketball game last night, Mrs. Meister reached her hand into a bucket. Everybody put their name on a ticket. You had a chance to win a basketball signed by Richard Pitino. She reached her hand in a bucket. Everybody had an equally likely chance. That was a random sampling. All right, so we're going to very quickly look at example 1 on page 766 in your book. This is about a baseball sports writer. He wants to survey college baseball coaches about whether they think wooden bats should be mandatory throughout college baseball. What type of sample is described? Part A, the sports writer contacts only the coaches that he has cell phone numbers for in order to get a quick response. Well, if he only has cell phone numbers for certain people, that's convenient for him. He doesn't have to research and find out the names of all the coaches in the U.S. He already has their contacts. That would be convenient for him. Part B, the sports writer mails out surveys to all the coaches and uses only the surveys that are returned. Well, if only the surveys were returned, that means when the coaches got the survey, they decided, yeah, I don't want to do this, I'm going to throw it away, or sure, I'll fill this out for this guy. So it was a self-selection process. Those coaches decided or not whether they wanted to be involved, so they went ahead and sent them in. That would be considered self-select. 2 other definitions we need to know talk about the type of sampling, whether it is biased or unbiased. If you have a biased sampling, that means it either over or underrepresents the population you're talking about. If you have an unbiased sampling, it is a good representation of the population you want information about. So we would hope to have an unbiased sampling whenever we're doing some kind of a survey. Now we're going to look at example 2 on page 767. The manager of a concert hall wants to know how often people in the community attend concerts. The manager asks 50 people standing in line for a rock concert how many concerts per year they attend. Tell whether the sample is biased or unbiased. Well, if the people are already standing in line for a concert, they probably go to concerts a lot. So this would be considered a biased sampling. It's over-representing your population. If this concert manager would have gone and stood, say, in front of the Dairy Queen, people are at the Dairy Queen to get ice cream. So if he would have been standing at the front of the Dairy Queen and asking people, hey, do you like to go to rock concerts? That would be an unbiased sampling. Rock concerts and going to the Dairy Queen don't have anything in common. So that would make more sense in terms of getting a true representation of your population. Let me give you another one. Say, for instance, I go to the dog park and I talk to all the people who are at the dog park and ask them, hey, I'm hearing that they're interested in building another dog park. Would you like to have another dog park in town? That would be a biased sampling. The people at the dog park are probably there because they like taking their pet to the dog park. Different example, what if I went to the dog park and asked people, hey, do you like pizza? Pizza and being at the dog park have no correlation at all, so that would be an unbiased sampling. I'm asking people if they like pizza. They're at a place that is totally unrelated to pizza. I get a better sampling, so that would be considered unbiased. The other thing we need to talk about in this section is something called a margin of error. Now this particular formula needs to go in your notebook, and it also needs to go in your cheat sheet for Chapter 11. Your formula for margin of error, E equals plus or minus 1 over the square root of n. N refers to the total population of who it is that you're taking the sample of. I have an example here. We're going to survey 1,535 people. 48% preferred brand A over brand B. What is the margin of error, E? Well, all I have to do is take my number of 1535 and plug it in into your equation. Plus and minus 1 over square root of 1535. So if you have your graphing calculator handy, 1 divided by square root 1535 equals, we get 0.025. Now remember, this is going to be a percent, so I'm going to have to take my decimal point and move it over 2 spots. So I have 2.55. Let's go back to my slide. 2.55%. Now remember, this is plus and minus, and that plus and minus is significant here because the second part of the question is, what is the more likely interval of people who prefer brand A? Well, they gave us a percentage at first. They said 48% of the people prefer brand A, but there's no way that you could ever survey everybody in the entire world. So they're obviously using just a sample of people. Well, that sample of people will give me a good idea of how many people like it, but it's never exact. So it's always within a particular margin. So what I need to do is take my 48% and I have to add my margin of error of 2.55. I also need to subtract my margin of error of 2.55. So it's 48% plus and 48% minus the error value of 2.55. That's going to give me a margin. And that margin of value can be written like a betweenness. You can put your low number on the left, your high number on the right. So we're just going to add these together. 48 plus 2.55, 50.55. And on the low end, 48 minus 2.55, 45.45%. So what is the more likely interval? Anywhere between 45.45% and 50.55% of the people in the population prefer brand A over brand B. We can also use this margin of error question and go backwards. If the margin of error is plus or minus 2.9%, how many people were polled? So in this particular sample, I don't know how many people I started with, but I know the error. So I can use my error value and go backwards with the formula. So remember again, your formula, plus and minus 1 over square root of n. I do know the error, 2.9%. Well, if I go backwards and get my decimal value, 0.029 equals plus or minus 1 over square root of n. I need to try to solve for n. So the first thing I need to do is get rid of this square root. So how do I get rid of square roots? I have to square everything. The square, when I do the right-hand side, 1 squared is still 1, plus and minus. Squaring a positive stays positive, squaring a negative turns positive, so my plus and minus sign is going to disappear. This is going to leave me with 1 over n equals. And then if you square 0.029, your calculator is probably going to show up with an e value, 8.41 e negative 4, 0.000841. Okay, so let's go back to our calculator for a second. I'm doing point. .029, and I need to square that. 8.41 e negative 4. Okay, so if I would move my decimal point 4 places, I had that .000841 that I was talking about. Let's go back real quick. .00841. Now what I need to do is try to solve for n. So if I multiply by n on both sides, I have .000841n equals 1. And now I need to get rid of the value, have n by itself. N equals 1 over .000841. Okay, so let me go back to our calculator again. I'm doing 1 divided by my answer. Okay, so my answer is showing. Now remember, there's a way in your calculator where you can just do 1 divide by that answer. 1 divide by my answer, second, and then way down here in the bottom, above the negative sign, is the word ANS, answer. 1 divided by my previous answer should come up with my value, 1,189.06. Now remember, this is talking about a population. This is people. I can't round up. So 1189 should be my population. If the margin of error was plus or minus 2.9%, how many people? 1,189 people. Okay, so this section was predominantly vocab. You have, let's go back again, population and sample, self-select, systematic, convenient, and random, self-select, pick me, systematic, follow a pattern, every other person, or so on, convenient, easy for the giver, and random, put a name in a hat type of thing. Biased versus unbiased, and then 1 formula. Make sure you get your formula in your notebook and your Chapter 11 cheat sheet. Now you are ready to go ahead with your assignment from Section 11.4.